This is the first video of a series covering the Physics 110 GR archive for GR2. This first video we're going to be looking at questions 1 and 2, if time permits. So if we're taking a look at question 1, we're starting off with two objects that have masses m1 and m2, and they have the same kinetic energy. If m1 equals 4m2, how do their velocities compare? So a big thing about physics problems is you just have to look at the verbiage of all of the questions, because there are normally a couple hints. So with this one, tells us that we're looking at same kinetic energy. So we know we're dealing with some equation that involves K. We're given a relationship between our two masses, and then we're asked to find how their velocities compare. So it's nice knowing where we need to get to, what answer choices we have, but the link between the two is we're given two masses and a relationship between them, and we need to get to velocity. A good way to do that is to use kinetic energy, and the fact that it tells us it's the same kinetic energy actually gives us a lot of hints. So if we start off by writing out a K equation for both of these, we would have the kinetic energy of m1 would be 1/2 m1 v1 squared. Same thing for kinetic energy of 2, except we're going to change all our subscripts because these are different masses. But what it says is we have the same kinetic energy. That's the same thing as saying this equals this. Or we can just set these two equations equal to each other. So if we rewrite this, we have 1/2 m1 v1 squared equals 1/2 m2 v2 squared. Okay, so now we have two equations that seem identical. The thing that differentiates them is the relationship between m1 and m2 from up here. So what we're going to do, we're going to take this, and we're going to substitute it in, because we need to see how the relationship between the masses affects the velocity in these equations. So we have 1/2, m1 is now 4m2 times v1 squared. And then we just copy the right side because that didn't change. So now I need to start simplifying things, canceling things out, because that is way too many terms to get us to an answer on our left side. So if we look at this, I want to get rid of those 1/2s. Since there's a 1/2 on both sides, it's really easy to just multiply both sides by 2. And that cancels that out. Rewrite this as 4m2 v1 squared equals m2 v2 squared. Okay, we have an m2 on both sides, which means we can just, if we were to divide by m2 on both sides, those would cancel. I'll write it out just for ease of visualization. m2 cancels on both sides, so then we're left with 4v1 squared equals v2 squared. So we're really close to getting something that looks more like our answer choices. The only thing we have is we have both of our velocities squared right now. So, way we get rid of a square root, we're going to square root both sides. Square root of 4 is 2, v1, and the square root of a square is just itself. So 2v1 equals v2. If I'm looking at my answer choices, there's not one that has it in that form, so I'm just going to rearrange this. We can just divide both sides, divide both sides by 2. I'm left with v1 equals v2 over 2. Okay, and if we look at our answer choices, looks like we got this one right here. So D is the answer for that one. Okay, number 2, an elevator is rising at constant speed. Consider the following statements. Gives us 5 statements. I'm gonna look at this first initial part of the question and highlight this constant speed, because that gives us a hint later on. So if we look at this, this is I, double I, triple I, V, and V. So we're looking at this first one. The upward cable force is constant. So let's draw out a picture of what this looks like. We have an elevator. It's going to be a box. We've got a cable pulling it. And then we have, in our free body diagram, some weight, the force of gravity. And a force up is the cable. Force of the cable. So, the upward cable force is constant. Good thing about this one is there's no external forces on this elevator. We only know it's there's weight pulling down on it and the cable pulling up on it, which means that if it's moving at a constant speed, that means that constant speed means acceleration is 0. So that means if we use Newton's law, sum of forces equals ma, and that means acceleration 0. So that means sum of forces equals 0. That also means, or we can derive from that, if there's only a force up from the cable, and there's only the force of weight going down, then that just proves to us further that the force of the cable equals the weight, which means the force of the cable isn't changing because the weight of the elevator isn't changing. So we can assume that I is true for now. So we can cross off number 2, or answer B, C for now. So now let's look at double I. The kinetic energy of the elevator is constant. Okay, so this one is a little easier to see because we know kinetic energy, K is 1/2 mv squared. We know the mass of this elevator is not changing because it's currently moving, so we can't be adding people to an elevator as it's moving. So the mass is constant, so that doesn't change. The only thing that can change kinetic energy is velocity, if velocity changes. But, according to this question, the elevator is rising at constant speed. So, if we have constant speed and constant mass, then that implies that our K is constant as well. Therefore, 2 is also true. Let's see, that doesn't rule out any more answer choices for now, so let's keep moving. The gravitational potential energy of the Earth elevator system is constant. Okay, gravitational potential energy, also known as U sub G, can be written as mgh, or delta H. I'll write that as delta H. So however the elevator is moving up and down, it would change the gravitational potential energy. So, since this elevator is being pulled up and down, the gravitational potential energy can't be constant because the height is changing. The U can't stay constant if the elevator is constantly rising. So, 3 is false. So that also rules out this one, and it rules out the fact that all 5 of them are true. So at this point, we can assume that the answer choice would be E. If you want to know why 4 is correct, the acceleration of the elevator is 0. I kind of already said that because I was looking at the fact that this said constant speed. When there's a constant speed, the math equation that shows that is A equals V, A equals V minus V naught over T. Or I guess, here I'll write it as V final and V initial. So if V is constant, then this upper term is 0. And that makes acceleration 0. That's just a mathematical way to show it if you don't conceptualize that well. But since it's a constant speed, acceleration is 0. So that means that E is the correct answer for this one. And that's it for this video. We'll continue with the rest of the multiple choice in the next one.